Hi, today I'm going to be discussing AC electricity in both series and parallel circuits. Before we can get started, we need to know what AC electricity is. Electricity can be transmitted in two forms, direct current or alternating current, and as the name suggests, for AC electricity, the current supplied alternates by varying in both direction and magnitude with respect to time. This is due to the voltage alternating its polarity from positive to negative. AC can be represented as a sine wave when plotted with respect to time. AC differs from DC in that its current and voltage are constantly changing magnitude and polarity. However, both AC and DC follow the same electrical laws. There are two types of electrical circuits, series and parallel. In a series circuit, there is only one path for the current to flow through, whereas a parallel circuit has multiple paths for the current to flow through. Components on neighbouring branches that share a common node at each end are considered to be in parallel. When making calculations in AC, it is important to first simplify the circuit. The components I will be discussing in AC are resistors, capacitors, and inductors. To simplify the circuit, like components can be added together. Each element is added differently depending on whether it is in series or parallel. For a series circuit, resistors and inductors are simply added together, whereas capacitors must be added using the formula shown. For parallel circuits, however, capacitors can be simply added, and the resistors and inductors must be added using the formulas shown. Once the circuit is simplified, the impedance of each circuit component must be calculated, and then the total circuit impedance. Impedance is the measure of how much a component will impede or resist the flow of current through it, and is measured in ohms. Some components are frequency independent, such as resistors, whereas others are frequency dependent, and therefore their impedance will vary with the supplied frequency. For resistors, impedance is simply equal to the resistance. For capacitors, impedance, Xc, is equal to 1 on 2 pi Fc, where F is the frequency in Hertz, and C is the capacitance in farads. For inductors, impedance, Xl, is equal to 2 pi Fl, where L is the inductance measured in henries. Impedance can be represented using polar form or by rectangular form. When multiplying or dividing impedances, polar form is used, and when adding or subtracting, rectangular form is used. Once the circuit impedance has been calculated, the voltages and currents of each element in the circuit can be determined using electrical laws such as Ohm's law and Kirchhoff's voltage and current laws, as well as voltage and current divider rules. I hope you now understand how AC electricity works in both series and parallel circuits,